Remember this crazy little thing called long division? We'll worry about this now. The crazy little thing called long division. Let's say you happen to have 12, or let's see, 274,653. And I want to divide that by 12. And I'm going to use long division. Why not? I know, we have magical box. All right, you know what? Let's make it easier. Let's just make it 2,046. 2,746. I'm cutting the problem in thirds. Now, when you did this, you asked yourself, how many times does 12 go into which value? To 20, to 2. It doesn't go into 2, then we go to the 27. How many times does 12 go into 27? Twice. You put the 2 over that one. 2 times 12 is 24. And then what did you do?
And then you brought down the 4.
Okay, you subtract. We get 30, and then we bring down the 4. How many times does 12 go into 34? 2 again. So we had a 24 again. Subtract it out. We get 1, 0. Bring the 6. We have 106. Now, now, how many times does 12 go into 106? 9 is 108. So it would be 8 then, right? 8, that's 96, I believe, right?
Yeah.
I'm left with 10. Now, I have nothing left.
So you add a 0.
I could, but I don't want to. Remember, you guys would write it as remainder 10. But do you remember that this was the exact same thing as saying 10 over 12, 10 twelfths? Or in other words, we'd simplify it as 5 sixths. I guess. What we're doing here is we're using long division to go through. Now, in Algebra 2, we use long division with polynomials. And the process is exactly the same. If not, it might actually be easier. The reason why we use long division in this class is that it's going to set you guys up for helping to find what are called slant asymptotes next year. So we're setting the basic knowledge of how this works.
Wait, so we can't use calculators?
No. How are you going to use a calculator on this?
Oh, sure.
So here's what happens. Again,
Let's do it.
what happens is the book writes out stuff horizontally like that. When you use long division, what you're dividing by goes out here. What you're divided into goes here. When you put that underneath the divisor symbol, I don't know what it's called, you have to make sure you're in the descending order with no missing exponents. Remember when we used synthetic division, if we had a missing exponent, we put in 0 as a placeholder? We basically would have to do the exact same thing here. So I put in here the 2x cubed minus 7x squared minus 17x minus 3. Everything works out, descending order, it's the third degree, there's 4 terms, we're all good. Now, what's a little bit different between this and your regular old boring long division is that every time you do this, you're going to ask the same question. What do I multiply 2x by? What do I multiply 2x by to turn it into 2x cubed? That's my first question. X squared. Okay, I have to multiply it by an x squared. Bless you. Where do you think you're going to put that x squared? Are you going to put it above the x cubed, the x squared, the x, or the single? Above the x squared. Whatever exponent you're going to use, you're going to place it above it in the divisor area. Okay? Now, think about what you did in long division. In that example we had a second ago, when I put the 2 up here, I multiplied 2 times 12, and I wrote it here, right? What do you think I multiply x squared by? 2x plus 3. So then I get 2x cubed plus 3x squared. What do you think I do now? Subtract. Very good. I subtract just like I did earlier. Now, 2x cubed minus 2x cubed, it's gone. Good, that's what we wanted to do. Negative 7 minus 3 is how much? Negative 10. So it becomes negative 10x squared. What do I have to drop down now? Drop the negative 17. Ask the question again. What do I multiply 2x by now to turn it into a negative 10x squared?
Negative 5x.
Negative 5x, very good. So now I go above here, negative 5x. Multiply it over, I get negative 10x squared minus 15x. Subtract them again. Negative 10 minus negative 10 is 0, it's gone. Negative 17 minus negative 15. Negative 2. And then bring down the negative 3. And your last question. What do you multiply 2x by to turn it into a negative 2x? By negative 1.
Wait.
Multiply.
I don't.
And when you subtract them out, you're left with no remainder. And that's the answer. When you divide 2x cubed minus 7x squared minus 17x minus 3, divide that by 2x plus 3, you get that. Yes, if there's a remainder. Guys, great question. Will there ever be a remainder? Yes. And remember we had a remainder a second ago. We made it into a fraction. So if you had a remainder, you just made it into a fraction with this as the denominator. And I'm going to show you an example of that here in a second. What you're asking yourself each time that you do these is that when you write it out, you want to turn each of these numbers, you want to take this value and turn it into this, then this, then this, each time through. And that's eliminating that term to find out your answer. Okay? I'll show you another one. We're going to do this long division again. I have 2x to the fourth plus 3x cubed plus 5x minus 1. Now, when you write that out, does this one need a placeholder? Where does it need the placeholder? At the x squared. What are you going to put as the coefficient for the x squared then? Very good. Very good. So when we start the problem by writing out what's being divided. So I have 2x to the fourth plus 3x cubed plus 0x squared plus 5x minus 1 divided by x squared minus 2x plus 2. Remember, placeholder has to be there in order for this to work, just like synthetic division. Start with the question. I want to turn x squared into 2x to the fourth. What do you multiply it by? 2x squared. Where do I place that 2x squared above then? Above the x squared. Very good. All right. Distribute this to those. So you get 2x to the fourth minus 4x cubed plus 4x squared. I want to turn this x squared into a 2x to the fourth. What do you multiply x squared by to turn it into 2x to the fourth? Multiply by 2x squared. Now you subtract those three. 3 minus negative 4, 7. 0 minus 4. And then I got to bring down the 5x.
Can we just leave the negative 1 right there?
Yeah.
Until the next step?
Yep. You bring them down one at a time. Now I want to turn x squared into a 7x cubed. What do you multiply it by?
7x.
7x, very good. So I have 7x cubed minus 14x squared plus 14x. Again, subtract all three of them. Negative 4 minus negative 14 is positive 10. I have 10x squared. 5 minus 14 is negative 9. And now I bring down the negative 1. Yeah.
When you're doing all this, why do you
Because every time you divide out, you're trying to eliminate each consecutive degree, if you will. So the first time I eliminated the fourth degree, then I eliminated my third degree, then I eliminated my second degree, then I eliminated and so on. That's how this works through. You don't try to do it all at once. It just becomes really a big giant nightmare. It's very clean to go this way. What do you multiply it by now? How much? 10. Bring the 10, you get 10x squared minus 20x plus 20. Subtract. I have 29. I'm sorry, no. 11, excuse me. 11x minus 21. Now that's my remainder, if you will. There's nothing left for me to drop down. So when I'm left with that remainder, is that 11x a positive or is that 11x a negative?
Positive.
It's positive, so I have plus 11x minus 21 over x squared minus 2x plus 2. It mirrors the same idea as what we looked at a second ago when we divided out 12, went into, what was it? 2746. It mirrors that idea of 2746. We had 2, 2, 8, and then we had that 10 twelfths as that remainder. All we did there was just simplify to the fraction.
You get to simplify that.
No. You're just gonna leave it like that. Okay. Remember, I picked this number out of thin air, and it just happened to wind up with one that could simplify out. Yeah. No, I'm not gonna make you guys simplify that remainder, and that's it. It's a very systematic way of long division. Now, the other stuff we're looking at today is the synthetic division, which you guys recall from earlier in this chapter, where you just plucked your coefficients, dropped it, and you multiply and add, and it was a real fast process. Yeah, it's that little sideways L thing. Well, what's nice about synthetic division is that not only is synthetic division quicker and more efficient than this, but it also is going to allow us to factor, believe it or not. So let's look at some of that as well.
Isn't the negative 4x squared minus negative 14 18?
Negative 4 minus negative 14 would be negative 4 plus 14, so that's where I got 10. Okay. So let me show you guys this other sheet. Yes, sir. What was that? I'm sorry? The way you get the remainder is when you have nothing left over here to drop down, that's your leftovers. Whatever's there always goes over what you're dividing by. And that will work always. There's nothing left, when you have nothing left to drop from the underneath the divisor symbol. Dividend, is that called the dividend? Sure. When you have nothing left to drop down there, all you have to do is take that value and put it over what you're dividing by, and that's your remainder. The only thing I'm going to ask that you remember is whatever this leading term's sign is what goes here. Since this one was a positive, that's why I wrote plus. If it was a negative 11, I would have written negative 11, or minus 11x, and so on. Okay? Now, using synthetic division, you don't have to worry so much about larger polynomials. When you're using synthetic division, we're usually dividing by a binomial. For example, if I want to use synthetic division to divide x cubed plus 2x squared minus 6x minus 9, and I'm going to divide that synthetically by, we'll just start with x minus 2. Whenever I am using synthetic division, the main thing to remember is that you pluck your coefficients, put them in the descending order, in our little L, 3, 2, 1, and the constant, so I don't have to worry about any placeholders. I have a 1, 2, negative 6, negative 9. And if I'm going to divide that by x minus 2, the one thing you have to be very, very cautious of is you always divide by the 0. If x minus 2 is my term, what's the 0? 2. Okay? So if I'm dividing, if it wants me to divide by x minus 2, what I need to remember is that I have to divide by its 0. So I have to divide by 2. That's the trick when you're synthetically dividing out like this. That's the only trick. Now remember, from here it's just a matter of drop the first term. 2 times 1 is 2. 2 plus 2 is 4. 2 times 4 is 8. Negative 6 and 8 is 2. 2 times 2 is 4. Negative 9 and 4 is negative 5.
Yeah, so why can't it just be like that?
Like I said, the other one is kind of like a introduction. This one you're going to use a lot more. Now, here's the interesting thing that happens. Whenever you are dividing synthetically, your result will always be 1 degree less than what you started with. I started with a 3rd degree term. That means this is now, this is x squared, this is the x, and this is my constant. What is the negative 5 then?
Your remainder.
Your remainder. That's your remainder. So when I divide this synthetically, my answer would be 1x squared plus 4x plus 2 minus 5 over x minus 2. Yes, ma'am? I'm going to do another example. I'm going to do the same thing with the x plus 3. So when you divide that out synthetically, that would be your result. Remember, every time you synthetically divide, what happens is that your result is always 1 degree less than what you started with. Yeah?
I'm still not getting why you like to power.
You divide by the 0. Remember, if x minus 2 is your term, how do you make it 0? X would have to be 2. If my term is x plus 3, what's my 0? It's negative. Okay. So when I synthetically divide that by negative 3, I use the same coefficients. I'll move this up. 1, 2, negative 6, negative 9. I'm synthetically dividing by negative 3. First step to go through synthetic division, drop the first term. Then you multiply negative 3 times 1. You write it there. Then you add, going down, you get negative 1.
Oh, we shouldn't say minus it.
Then you multiply again, you get positive 3. You add, you get negative 3. You multiply, you get 9. You add, you get 0. Is there a remainder in this case? No. So when I divide x cubed plus 2x, or 2x squared minus 6x minus 9, if I divide that by x plus 3, my answer is x squared minus x minus 3. And that's my result. What synthetic division allows you to do real fast for these weird polynomials is that it's allowing you to figure out if something is a 0 of it or not. If something was a 0 of it, that means it had a factored term. Using synthetic division to factor is an extremely efficient way to factor. Very, very efficient. Okay? Very efficient. Let me show you an example. Oops. 2x cubed plus 11x squared plus 18x plus 9. And I'm going to factor this using synthetic division, knowing that my 0 is -3. That's what this means. F of negative 3 is your 0. That means that -3 is your 0. If -3 is your 0, what would the term be in parentheses?
3.
What was that? Very good. Okay. So again, if I'm going to synthetically divide that by factoring, given the fact that I have a 0 at -3, that means that my term is an x plus 3. That's the term. Synthetically dividing, my 0 goes here. Coefficients, 2, 11, 18, and 9. I don't have to worry about any placeholders whatsoever. Drop the first term. -3 times 2 is -6. 11 and -6 is 5. -3 times 5 is -15. 18 and -15 is 3. 3 times -3 is -9. And I get a 0. Do you agree?
Yeah.
All right. So that means that right now, I have 2x squared plus 5x plus 3. Could you factor that by hand?
Yes.
How?
Well, you times the 3 by 2.
What do you get?
6.
All right, so what times what's 6? You add the other to get 5.
3 by 2.
2 and 3.
Oh.
You're thinking to get 6 and you were adding, you're going the other way. So what's happening here is that you know you have a term of x plus 3 because your 0 is -3. So I know this is my 0, so this is my term. When I synthetically divide out by that first 0, it's giving me a smaller chunk to work with. That smaller chunk is usually going to wind up being a trinomial. And you guys can factor those a little bit more efficiently than you can the larger, crummy looking polynomials. So here, like Mamre was saying, this would give us 2x squared plus 2x plus 3x plus 3. And that's a relatively straightforward factor by grouping problem. You agree? Remember, the x plus 3 is still here. When I group this, I have a 2x and an x plus 1. And I have a 3.
Holy
So your your 3 factors would be x plus 3, x plus 1, and 2x plus 3. And that's your factored form of that polynomial. That synthetic division allows you to break it down into something smaller. Yeah?
Why is it x plus 3?
If your 0 is -3, your term is always the opposite sign. Remember when we had, if we were setting it and solving zeros, and you had x minus 2 was 0, your 0 was positive 2. We're just going the other direction now. So if I say your 0 is 2, that means your term is -2. It's just the opposite of what we've been doing. Yeah?
Okay, so if the whole function is -3,
Uh-huh.
why, or how did you?
That's just telling you that that is the 0. F of -3 is 0. That means that -3 is the 0.
Okay, so then it's,
That's what that, and you can just,
So
then why are you pointing it out after you?
because that I'm factoring it fully. So I know that the first factored term of that whole polynomial was x plus 3. And I'm using the 0 to find the other ones. We'll do another one. Later you have it.
That was my question.
Okay. Again, I have a 0 at 2. I have a 0 given to me at x equals 2. If my 0 is x equals 2, what's my term? So I know that I will have an x minus 2 as one of my factored terms. The function I'm looking at is x cubed minus 2x squared minus 9x plus 18. So I'm going to use synthetic division with my 0. My 0 is 2. Pluck out my coefficients. 1, negative 2, negative 9, and 18. I know that it's given to me that x equals 2 is the 0. And I have the function x cubed minus 2x squared minus 9x plus 18. And it wants me to find the other zeros, which basically means factor it. So drop the 1. You get 2 times 1. Add them, multiply them, add them, multiply them, and add them.
Now you just do
What's the result?
x
Term.
x squared minus 9.
It's very good.
And you just do x plus 9, x minus 9.
Whoa! What's x squared minus 9 when you factor it? X plus 3, x minus 3. Remember, and also, the reason I brought this in here, because it gave me my 0 at positive 2, which means my term is x minus 2. And I'm trying to find all of my zeros. So I'm just writing it along for the ride. So I have x plus 3, x minus 3, and x minus 2, all equal 0. So my lists of zeros, negative 3, 3, and 2.
How do you get x squared minus 9?
Remember, every time that you divide out synthetically, you're dropping a degree. So this is the x, this is my x squared, this is my x, this is my constant, and this is my remainder. All I'm left with is x squared minus 9. Okay? The results when you synthetically divide are always your coefficients of it in that descending order. Yeah? Right.
So we don't have that back up because we divided by the
Right, you're pulling out, you have to divide by this. You're always divided by the 0.
So when we're given the zero, automatically.
You just have to read the question. Check, great question here, guys. In that first example, it said divide by x plus 2. You notice how we divided by the 0 right away? And the other question, the other examples was giving you the zeros to divide by. You didn't have to change it. You just got to read it carefully. Yeah, Sean.
What happens if they're using?
When you're factoring, there shouldn't be.
Okay.
There shouldn't be.
Homework.
Well, I got a couple minutes.
Yeah, you do.
Yeah, right. You can always wish about that, right? All right, let's do another one. Again, let's try this one. I know that I have x cubed minus 8x squared plus 4x plus 48, and a 0 is 4. And I'm going to factor this and find the other zeros. So if my 0 is 4, what's the term?
X minus 4.
Good. So I know right away in this problem I'm going to have an x minus 4 at the very end. Since my 0 is 4, that goes out here. Again, we're just going to pluck out all the coefficients. 1, negative 8, 4, and 48. Drop the first term. 4 times 1. Add them. Multiply. Add them. Multiply. And you get a 0. Which means my new polynomial is x squared minus 4x minus 12, which is a trinomial that should be relatively easy to factor. What times what's negative 12? You add together to get negative 4. Very good. Other one. Yeah. So you have x minus 6, x plus 2. And up top we have the 0 already of x minus 4, or term. Gives you zeros of 6, negative 2, and 4. Factoring using synthetic division is extremely efficient. All right, it's extremely efficient. It's going to drop you a degree, and it's going to give you a term that should be easily factorable. Okay?
So we only grab the x minus 4 and then just have to go back.
Yeah. Give those a shot. Like Lena was asking earlier, just read the instructions carefully. If they're telling you to divide by x plus 2, make sure you divide by the 0. If the other ones are going to say 2 is the 0, then you just divide by 2. If you're getting weird answers, that's probably what you mixed up. Okay? Give those a shot and we'll see how we do tomorrow. Synthetic division is what we're going to be finishing up. The rest of these sections just kind of keep going with the same thing. Okay?